Welcome back to C++ Fundamentals, Part 2. My name is Kate Gregory, and I'm showing you around C++, the most popular general-purpose programming language. In this module, you'll meet my favorite C++ 11 feature, Lambdas. In theory, Lambdas don't add any new capability to your programs. Everything you can do with Lambdas could be done a longer or more complicated way using building blocks from versions of C++ before C++ 11. But that's theory. In practice, they really change everything. Let me show you why. To begin at the beginning, what is a lambda? Well, it's an expression that represents the idea of doing something, performing some operation or calculation. Typically, you will hand that lambda to something else. You'll very often see them as a parameter to a function call, for example. The idea of bundling up a calculation in general, lambdas take parameters, enables very different styles of programming within C++. You can obviously write a more generic style than you would without lambdas. You can write in a more functional style. It's a wonderful way to enable concurrency, but I'm going to start with the most accessible and simple reason for using lambdas, and that's simply for readability in eliminating teeny tiny little functions. Plus programs, especially when you're using the standard library, can really end up littered with tiny little functions like this one. Its name is print, it takes an integer, and it puts that integer onto the screen using cout with a space after it. Now, who on earth would write such a tiny little function? Well, someone who was going to use, for example, a for each function from the standard library to iterate through a collection. Here we have a vector, and in fact, this was a demo in a previous module of this course. The print function is really only there to be that third parameter to the for each call. Start at the beginning of the vector, go till we're past the end of the vector, and for each element in the vector, pass it to the function print. Each element of the vector is an integer, so the print function takes an integer, does something with it. When you see it like this on a PowerPoint slide, it's not so bad. I mean, you just have to flick your eyes up 3 or 4 lines to see what print does. Of course, in reality, print might be in an entirely different file from the code that calls it. Its name and what it actually does might drift over time. You'll notice that this prints the number followed by a space. Maybe later someone will change it to the number followed by an end line. Neither of those is captured in its name. And this sort of develops into an irritation, just a little stone in your shoe as a C++ developer who uses the standard library a lot. Having to maintain, name, keep track of, find all these different little functions takes away from some of the convenience of using the standard libraries for each and might make you want to use a language for instead. I'll show you how lambdas make that for each just as convenient and helpful as the language for. Instead of a tiny little function that might be thousands of lines away from the place that calls it, this for each will be a lot more readable if you use a lambda. Here's the start of that call again, setting up the vector, and I'm omitting the part where we magically put values into the vector. But now in the for each, instead of calling that print function by name, we can just put the body of the print function in here as a lambda. The first parameter and the second parameter to the for each call are the same as before, iterators to the beginning and past the end of our vector. The third parameter, instead of just being the name of the function that you want to call on each element of the vector, is in fact the operation that you want to do to each element of the vector. I'm going to go through the syntax of lambdas in quite a bit of detail, but just to see the basic parts, you have the beginning and end square bracket, which I generally tell people means, hi, I'm a lambda. Then in round brackets, you have the parameter that the lambda takes, in this case an integer. Then in brace brackets, you have the body of the lambda, which is, in our case, the body of the old tiny function. So that whole line is the third parameter to the function call. Then we have the close bracket semicolon because we've finished calling the function. So the lambda is right in place. You can easily see what it does. You don't have to come up with a name for it that's different from the name for some other tiny function that you've used before. Your code becomes more readable. It's also quicker to write. I've put a solution together so you can see this lambda in action. Here we declare a vector of ints, fill it with the numbers 0 through 9, just using a language for, and then I have a for each call. This is exactly the code that you saw on the PowerPoint. From v.begin until we get to v.end, the square brackets say, hi, I'm a lambda. Round brackets, I'm a lambda that takes an integer, and what I do with it is I print it onto cout, followed by a space. And I've got it all on a single line. Let's just run up to this point so you can see the output. It prints out the numbers 0 through 9. Hopefully not a surprise. People often want to debug lambdas and can find it a bit of a challenge, especially when it's all on one line like that. I've got the exact same lambda just written out over multiple lines, and I'm going to show you how to debug through it. I'll step over this line that prints out a line of dashes, and now we are on this function call to the for each, and I'm going to step into the call. And as part of doing the call, we'll be evaluating the parameters that were passed to it, the begin and the end to start with. Here we are inside the end function that returns an iterator. I'll step out of that and step in again. We're in the begin function that returns an iterator. Step out of that. Step in one more time. And we're actually in the for each that is going to step through the vector, processing each element in turn. So I'm going to step into this. This just has to do with some internals of the standard library that I'm really not going to discuss. They're fairly, as you can tell, boilerplate. And now here we are, as the comment says, actually performing function for each element. And if we were doing this the old style way, func would be print or whatever the name of that function is. But now it is this lambda that we've passed all the way down to here. So if I just flip out, we haven't written anything yet onto the screen. Now if I step in here, you can actually see that the debugger is showing you the code of the lambda. It took a lot of going through some internals of the standard library to get to here, but now you can actually use our familiar debugger controls. That was one iteration, and the 0 got printed out. Step in again. Again, I find myself back in my original code, can use the step over controls, can hover over things and see what they are. We're on 1. And if I Alt Tab, now 1 is on the screen. So if people tell you you can't debug lambdas, you absolutely can debug lambdas, but it takes a little patience when you find yourself in that converting checked and unchecked iterators back and forth and general weirdness to kind of hold on with a little faith, keep hitting step into, you will find yourself in your Lambda code should you need to debug it. Now I just want to carry this on. Let's just run this down to here. to show you that a lambda not only doesn't need to be on a single line, it doesn't need to be a single statement. Our sort of canonical first lambda has only one semicolon in it. Down here, I have one with multiple statements. And what it does is prints the number out, and then if that number is even, it prints out the word even, otherwise it prints out the word odd. Just going to run down to that and show you the output. Hopefully no one's surprised at the oddness and evenness of the numbers 0 through 9. Just to show that this lambda, which goes from here to here, has multiple lines, multiple statements. You could also debug this and watch control go in and out of the different if or else blocks according to the number we were testing. This is still pretty readable.